Hola, mi amiga. I keep wanting to say V Gates. ¿Cómo estás? That's what it is. V Gates is the German I took in high school. So, hey, I'm going to email you this spreadsheet that I'm working on right here as soon as I get done this. I was going to explain it to you in email, but I think it's actually easier just to do it with a video like this. So I'll upload this to YouTube and you can watch it and then you can crack open the spreadsheet and take a look. So all I did here, I took your little sheet here and I ripped out everything I needed, which are the section numbers here, locations actually, and then the totals, and then the ones that got released. And I summed them up. I'm going to ask either you or whoever to just make sure. I did this manually. I was trying to write a formula to do it, but then I realized that writing the formula would take me more time than I had today. So I just ended up summing them all manually, but with the sum command, and then I copied and pasted the values in here. So you got your 66 regions, and then over here, I can delete this actually down here. Give me 1 second. Delete all this. And then free format. Sorry, just talking to myself while I'm working. Okay, that's good. And yeah, whatever. This is fine. And then what I did, for some reason I thought this would be important, so I did the dead as well, which is just the difference of the total from the living. And then I did the percentages based on the regions. So this one right here is the percentage of C releases, 678 out of 739, and this one is just whatever's left over to get to 100%. Okay, so here's the normalized. This is where the interesting stuff started happening, and I need to figure out what's going on. I normalized the box values because all these totals are different, and they're vastly different. If you look at the minimum's like low 600s, and the max is over 900. So we clearly can't be using just raw percentages to compare them because of the differences in the numbers. So I just threw for starters an average. I said let's just use the average of all the regions. So the average from 739 down through whatever that was. So it drops to 761 in here, and then I applied the percentage here in each of these cells to that 761 to say, okay, we'd have this many turtles that would live then. This many turtles would be alive. And this is probably too much decimal accuracy. Probably don't want all that. I'll shrink it down a little bit. There's to the nearest whole. Actually, I probably should leave. Well, whatever. It doesn't matter. You can always add it back in if you want it. And then over here, I just took whatever the difference was from that to get to 761. So again, normalized dead, normalized C. And I'm not even sure if normalized is the right word. It's just equalized, I guess. So assuming, just to give you an example, that this region had a 92% survival rate and this region had an 87, that would mean you'd have this many turtles and this many turtles on an equal numbered box. Okay, this is what we chatted about yesterday on the phone with each other. So I'm going to move over a little bit. So that's the Sean's prep of data sheet if you're interested in that. Then what I did here was, this is the actual chi-square test I was describing for you. So here are all those observed values from this sheet here. So this pulls the value 698 in from here. It just pulls it over to here. So here's all those observes all the way down to the 71, okay? So you end up with 66 categories, which we knew. I counted it with Excel just to make sure. The expected values, this is kind of the fun part. I took the sum of all these values. So I took all these, whatever eggs we got here, it ended up being 44,000 some eggs, and then divided that by the 66 regions. So I took that 44,000 eggs and spread it across the 66 regions, and that, hopefully you see, that's all the same all the way down. And this makes me happy because there are going to be some that are low and lower than that, some that are higher than that. Okay, and that's, I guess that comes from the feature of using the average nest box size. Okay, so I'm walking through this with you. Don't worry about this column right now. We'll deal with that in a second. Here's the chi-square actually happening. So you can ignore the isBlank command. This is just a generalization you can use for more than one situation. Let me zoom this in too, make it a little bit easier to see. So all this is doing is it's taken the observed value minus the expected value, squaring it, and then dividing by the expected value, and then that just copies all the way down for all the categories, all the way down to whatever that is, 71, I think. Okay, so that does all that. So you've got all those little error terms, all those offnesses. Your chi-square test statistic, I've got this set to M15. I summed that. So all that is it's the sum of all this. I must have that over an M15. I'd forgotten about that. So That sums up to your 83.45. And then this is the actually interesting number. This is your p-value based on that test statistic. So you got your test statistic up here. Here's your p-value. It's just over 6%. We're going to come back to that in a second, based on this many -1 degrees of freedom. Okay, so since you got a quote-unquote big p-value, that means that there's no reason to do a post hoc test. Now, up here, if you look up here, I've got your Bonferroni, however you say that guy's name, correction taken care of here. So this one is the one where you take the significance you want and divide it by the number of categories, and that's the significance you actually have to test at. And then everything down here is the setup for the post hoc if you need to run it. Now, it's because this is waiting to go in case you need it. Now, we don't need it here because nothing came back significant. So there's nothing to post hoc test on. Here's a visual if you want it. You got too much shading. So there's not enough, there's too much area to warrant a post hoc test. So in other words, based on the assumption that we use the average number of boxes for the normalized number, there's nothing to talk about. Okay, I want to come back to that because I learned something as I was messing around with this, setting this sheet up for you. And I can't explain it yet. I want to think about it more tomorrow and on my bike ride home. I also decided to take the dead normalizations and run a chi-square test for them. And lo and behold, it's exactly the same sheet. It's just copying the dead data down and the expected number of dead. It's all the same, right? You take the sum of all the dead turtles and divide it by 66, and lo and behold, not only do we get a little tiny p-value. Okay, this graph is off. It's looking at the wrong data. I'm going to delete. No, I'm not. I'm going to do select data. Okay, you know what I'm going to do? I'm going to fix this graph. This graph is wrong. This should have almost no area shaded, and the reason is because I copied this graph over from a different spreadsheet. I will clean that up and send it to you fixed. So these graphs you should see almost no area on this graph because you're seeing essentially a 0% p-value. I mean, there's nothing here because this chi-square value is out so damn far. And the same thing goes for this one. This one's also wrong because it should be at 83, and 83 is over here. Nonetheless, I'll fix all that and send it back to you. The problem is I am getting significance with the number of dead. So in other words, this is getting flagged using Bonferroni because we've got too many dead turtles. This one's getting flagged because we have too few. This is the first thing that kind of is making me kind of scratch my head and go, but why? If there weren't too many alive turtles, why are there too many dead turtles? So what I need to go back and look and figure out why that difference is it exists. I'm hoping it's a simple little math mistake. If it's not a simple math mistake, there's something fundamentally maybe wrong with this normalization idea. That's the first thing I noticed. And then when I was testing your sheet, check this out. I originally didn't have 761 as a box value. I used the minimum box value. So I actually typed in min, and then I used the minimum of all the boxes. Okay, and the minimum ends up being 641. That's the smallest one. And that'll update, all this stuff will update over here. And all this stuff updates over here. And what I noticed, it's kind of hard to see, but these post hocs changed. They're now different. They're pointing to different numbers. And even crazier, I just started messing around. Let's just, for shits and grins, change it to 100 just to make it literally percent. All of a sudden, nothing. And then I kept messing around with it. Like, well, let's make it something ridiculous. Let's make it 10,000. And then I started getting flags in the turtles released to sea and a lot more flags. So I want to think about this more before we commit anything to it, because that should not be happening, right? If the math that we're doing is sound, it shouldn't matter what normalized box value we're getting. So what I'm thinking is happening is I have to look at the actual calculation of the chi-square a little bit more and do a little more research on it. There might be a suggested value of this we should use for the normalization. I like the idea of using the average, but I have no idea if the research tells me I should use the average. So I'm going to leave it when I send it to you as average. For now, let me think about this some more. I have to head home now. Unfortunately, it's 5 o'clock. I got to go home and make dinner for the fam. But I just want to let you know that I got to think about this some more, because something weird is happening, and I'm not sure if it's because a math error I made somewhere in this spreadsheet, or if there's something fundamentally wrong with what I'm doing. So anyway, I just wanted to pass that on and let you know what I was thinking about, what I was working on. I'm going to send this spreadsheet to you in a second. I'm going to upload this video as well, and we'll chat more soon. I can't do the other spreadsheet work today because I need to get home. So I will chat with you more when we have time, and we'll talk to you on the flip side. Hasta la vista, hasta luego, buenos tardes, gute Nacht. I'll stick with that. All right, I'll talk to you soon, my friend. Bye-bye.